So the second half, and maybe the part 2 of 3 of section 2.2, we're going to learn how to take derivatives when we have fractions. And if there's a fraction, generally I always use the quotient rule. In rare instances, I'm able to bypass the quotient rule by rewriting the problem so it's no longer a fraction. But if there's fractions and there's an x in the denominator, the quotient rule is probably the way that we want to find a derivative. So let me just write down what the quotient rule is. The quotient rule is used to find the derivatives of fractions when there's an x in the denominator. And the quotient rule basically says you can find the derivative of any fraction if you take the denominator and you multiply that by the derivative of the numerator. Oh, there's not enough room to write it here. Let me just go here with it. Crud. Writing so big. So the quotient rule. Says if you have a function f of x, the derivative of that function can be found by taking the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, derivative of the denominator, all over the denominator squared. So let me just jump right into it, show how to use the rule. It's an easy-ish rule. Sometimes the simplifying is a little bit nasty. So if I was doing problems 15 or 16, they're a fraction. Fractions can be found. The derivative can be found using the quotient rule. So anytime I see multiplication, like in the first 14 problems, I think product rule. When I see division, I think quotient rule. So problem 16, which I'm about to do here, I'm going to find the derivative, and I need to know 4 pieces. I need to know what the numerator is. In this case, the numerator is 7x minus 4. I need to know the derivative of the numerator. The derivative of 7x minus 4 is just going to be 7, because the first term, if I find its derivative, it's the first power term. Its derivative is the number in front of the x. The second term is a constant, so it has a derivative of 0. I need to know the denominator. The denominator is 3x plus 11 in problem 16. And I need the derivative of the denominator. The derivative of 3x plus 11 is just 3. The derivative of the first term is 3 because it's the first power term. First power terms have the derivative of the number in front of the x without the x. The second term is a constant. Numbers without letters have a derivative of 0. So in problem 16, if I wanted to apply the quotient rule, I'll write my derivative symbol, the little prime. I'll form a fraction. The first thing I'm going to write is the denominator. The denominator is 3x plus 11 because it has 2 terms. I'm going to put it in a parentheses. So the denominator times the derivative of the numerator. The derivative of the numerator is 7. And then minus the numerator, 7x minus 4. So the second piece goes after the minus sign. It's the numerator, which is 7x minus 4. It's a binomial, so it needs a parentheses, times the derivative of the denominator. The formula says to put the 3 right here, the derivative of the denominator. Quite honestly, it's going to be a lot easier to follow my simplification if instead of putting the 3 after the parentheses, I put it before the parentheses. So for these, I might flip-flop the order from time to time if it makes it easier to do the simplifying on the next step. So instead of writing the derivative of the denominator second, I'll write it right next to the minus sign. And that's the numerator part of the derivative, and then all over the denominator squared. I never ever FOIL out the denominator. I'm just going to leave this squared. These can't cancel. You can't cancel the 3x plus 11 in the numerator unless there was a 3x plus 11 in a parentheses on both sides of the minus sign. So it would be illegal to cancel those right now. So that's the derivative using the quotient rule. Denominator times derivative of the numerator minus numerator times derivative of the denominator. Wrote that backwards all over the denominator squared. This will never cancel. Now let me just simplify. I never FOIL out the denominator, but I usually combine like terms and FOIL out the parentheses in the numerator. So in the numerator, I'm going to clear the parentheses by going 3x times 7 and get a 21x, 11 times 7 and get plus 77, minus 3 times 7x and get a minus 21x, and minus 3 times minus 4 and get a plus 12. All over 3x plus 11 squared, the quantity 3x plus 11 squared. Now I'm going to combine like terms in the numerator. The 21x's are opposites and they cancel. The numbers have the same sign, and so I'm going to add them and get 99, I guess, or 89. 77 plus 12 equals 89. So the numerator is going to simplify to the number 89. And a 3x plus 11 can only cancel with another 3x plus 11, so that 89 won't cancel with the 3x plus 11 squared. And that's just going to be my answer for number 16. So give 15 a try. Hopefully you can use this template. Your numerator, your denominator, you need the derivative of each, and then just the formula. Denominator times derivative of the numerator minus numerator times derivative of the denominator all over the denominator squared. If it helps, I'll do 17 and not do 18. So if I looked at 17, it's a fraction. Fractions generally force me to use the quotient rule unless I know how to get rid of the fraction. In this case, I don't know how to. So I'm going to write down the numerator, which is 9x, the derivative of the numerator. It's a first power term, so the derivative is just the number in front of the x without the x. So the derivative of 9x is just 9. The denominator, which is x minus 5. The derivative of the denominator. First term is a first power term. The derivative of any first power term is the number in front of the letter without the letter. There's an implied 1 in front of there, so the derivative of x is just 1. The derivative of minus 5, because it doesn't have a letter, is 0. So now I'm going to use the formula to find the derivative of number 17. So for 17, I'm going to say y prime equals, form a big fraction, the denominator, which is x minus 5, put it in a parentheses because it's a binomial, times the derivative of the numerator, which is 9, and then minus the numerator, which is 9x, times the derivative of the denominator. I don't need to flip-flop there because multiplying by 1 is not worthy of writing it opposite. But I could have written the 1 before the 9x. I could have written minus 1 times 9x. And then all over the denominator squared. So the denominator squared is going to be that x minus 5 quantity squared. Again, you can't cancel the x minus 5s like this. If there was an x minus 5 in a parentheses on both sides of the minus sign, then you could cancel. But this would be illegal to cancel. So now I'm going to just clear the parentheses in the numerator. I'm going to go x times 9 and get 9x. Minus 5 times 9 and get minus 45. And then this piece, anything times 1 is itself, so minus 9x times 1 is minus 9x. I never FOIL out the denominator. I always just leave it with the exponent. and I'm going to combine like terms in the numerator. These 9x's are going to cancel, and that's just going to give me minus 45 over x minus 5 squared for my answer. This won't simplify, and x minus 5 can only cancel with another factor of x minus 5 in the numerator. All right, so let's move on to 19 and 20. I'll do 20. You can give 19 a try. So for 20, I need to know, so I'm doing 20, the numerator, which is 3t squared minus t. I need the derivative of the numerator. The derivative of 3t squared, I go 2 times 3 is 6. Lower the exponent and get 6t to the first. The derivative of minus t, because it's a first power term, it just has the derivative of the number in front of the letter without a letter. There's an implied minus 1 in front of that t, so the derivative of minus t is minus 1. So numerator 3t squared minus t, derivative of the numerator 6t minus 1. Denominator for me, it's written in a bad order, but I'm going to leave it in that bad order, 5 plus 4t. And then derivative of the denominator, the derivative of the first term is 0 because it doesn't have a letter. The derivative of the second term is 4. It's a first power term. The derivative of the first power term is the number in front of the letter without the letter. So now I'm going to use the rule to find the derivative. So for number 20, I'm going to write y prime equals denominator 5 plus 4t. It's a binomial, so I'll put it in a parentheses, times the derivative of the numerator. It's another binomial. I'll put it in a parentheses. So that's denominator times derivative of the numerator, and then minus numerator 3t squared minus t times the derivative of the denominator. This is where the 4 I could write after the parentheses, but this is where I flip-flop it sometimes, and I'm going to write that 4 before the parentheses as opposed to after the parentheses. It's going to make it easier to simplify. And then all over the denominator squared. Never FOIL out the denominator, and that's illegal to cancel. Done with doing the derivative. Now it's just cleaning up the numerator. So I'm going to clean up the numerator and get to my answer. First part of my numerator is FOILing. To clean it up, I'm going to go 5 times 6t and get 30t. 5 times minus 1 and get minus 5. 4t times 6t and get plus 24t squared. 4t times minus 1 and get minus 4t. That's the first half of the numerator. Second half, minus 4 times 3t squared is minus 12t squared. And minus 4 times minus t is plus 4t, because a double negative turns into a positive. So that's getting rid of the parentheses in the numerator. I never ever, when I'm doing the quotient rule, FOIL out the denominator. Now I'm going to try to combine like terms. I'm going to do the squares first. I'm going to go 24t squared minus 12t squared. And when you're adding or subtracting, only the numbers in front of the letters change. The letters don't change. 24 minus 12 is going to be 12. So part of my numerator is going to have a 12t squared. And then I'm going to do 30t minus 4t plus 4t. The 4t's cancel and you're left with a plus 30t. The piece that I didn't deal with yet is the minus 5. I could write this 4t plus 5 squared, but I didn't. So that's the numerator. I don't see a common factor. I want to see if this actually factors. So I'm going to try my sneaky program. Program quad A equal to 12, B equal to 30, C equal to negative 5. Decimal, so it doesn't factor. Numerator doesn't factor. The denominator of 5 plus 4t can only cancel with a factor of 5 plus 4t in the numerator, so that's not going to cancel. And that will be my answer. 19 should work very similarly. So let me do 21 just in case you're getting overwhelmed. If you're feeling good about 21, just do it and then pause the video, do it, and then watch me do it to see if you can match up with my work. So for problem 21, I'm going to do the numerator, which is x squared plus 3, and then the derivative of the numerator. The first term, I'm bring the 2 out front, lower the exponent by 1. The derivative of x squared is 2x to the first. The second piece doesn't have an x, it has a derivative of 0. So the derivative of the numerator is just 2x. And then the denominator, 2x minus 4. The derivative of the denominator, the derivative of 2x is just 2. The derivative of 4 is 0. For my derivative, using the formula says, to find the derivative, I'll write the denominator, 2x minus 4, put it in a parentheses because it's a binomial, times the derivative of the numerator, which is times 2x, doesn't really need to be in a parentheses, but I could have put that 2x in a parentheses, minus the numerator, x squared plus 3, times the derivative of the denominator. This is when I usually write it backwards. And so instead of writing the 2 after the parentheses, I write it before the parentheses. And then all over the denominator squared. There is a common factor of 2 in the denominator that I maybe could factor out, but I usually don't do anything with the denominator, so I'll stay consistent with that. These 2x minus 4s can't cancel. There'd have to be a 2x minus 4 to the right of the minus sign to be able to cancel it. That's the derivative. Now it's just simplifying out the numerator. So I'm going to go 2x times 2x and get 4x squared, minus 4 times 2x and get minus 8x, minus 2 times x squared and get minus 2x squared, minus 2 times positive 3 and get minus 6, over the quantity 2x minus 4 squared. Combine like terms in the numerator, that's 4x squared minus 2x squared. That's going to give me a 2x squared. The minus 8x and the minus 6 aren't like terms to each other, so they just carry on. There's definitely a common factor of 2 in the numerator that I should factor out. When I factor out a 2, I just divide the numbers by 2. I take that 2 away, I divide those numbers by 2. That's sneaky. It looks like it's factors, but it's prime. I'll show you that it's prime real quickly. If that minus 3 was a plus 3, it would factor, but if I tried to factor this by entering 1 in front of the x squared, minus 4 in front of the x, and minus 3, gives me decimal, so it's prime. As you could actually see that. So this is a perfect answer for problem 21. So 23 and 24, keep mushing along. I really don't care to do those, but I will. So for 24, and you can do 23, I'm going to do 24. You know, fast forward through the video if you don't need to watch me do 24, do 23 and check your answer. I think I'm going to wind up skipping 25 and 26. Those don't ever come on a test, and I think they're just more complicated than we ever need to see, and there's nothing that complicated in Math 218 if you need to take that. So let me do 24. The numerator is 3t squared plus t minus 2. The derivative of the numerator, the derivative of 3t squared is 6t. The derivative of t is just the number in front of it, which is 1. And the minus 2 doesn't have a letter, so it has a derivative of 0. The denominator is 5t plus 9. And the derivative of the denominator is just going to be 5. First piece is a first power term. The derivative is the number in front of the letter without the letter. Second piece doesn't have a letter. It has a derivative of 0. Now I'm just going to use the quotient rule. I'm going to write k prime of t equals fraction, the denominator, 5t plus 9, times the derivative of the numerator, 6t plus 1, minus the numerator, 3t squared plus t minus 2, times the derivative of the denominator, and I usually flip-flop that just to make it easier. So that's the ugly part, and then all over the denominator squared, so all over 5t plus 9 quantity squared. Now I'm just going to clear the parentheses in the numerator, combine like terms. Again, these 5t plus 9s would be illegal to cancel those. So cleaning up the numerator, so k prime of t equals to FOIL. 5t times 6t is 30t squared. 5t times 1 is plus 5t. 9 times 6t is plus 54t. 9 times 1 is plus 9. That's the foiling part. And now minus 5 times minus 3 squared is minus 15t squared. Minus 5 times t is minus 5t. Minus 5 times minus 2 is positive 10. Always just leave the denominator, never FOIL it or do anything with the denominator. Now I'm going to combine like terms. I'm going to do 30t squared minus 15t squared by just going 30 minus 15 and leaving the t squared. That's going to give me 15t squared. And then I'm going to do plus 5t plus 54t minus 5t. So I'm going to go 5t plus 54t minus 5t. These 5t's cancel and you're left with the 54t. And then I have the plus 9 and the plus 10. And that gives me a plus 19. I don't think there's any common factors because 19 is a prime number and 19 doesn't go into 15. I'm assuming that numerator is prime and that what I've written here is my answer. I'm going to check to see if the numerator is prime. Super easy to do that. Program quad 1, 15 for A, 54 for B, 19 for C, prime because of the decimals. So that would be a perfect answer for problem 24. So you should be able to give 23 a go. I'm making a vote now because I know what we need for the rest of the chapter. I know what we need in Math 218. And the next few problems, while when I wrote them seemed so interesting, I think when I wrote these problems I hadn't taught Math 212 for a while. And they're probably at a level of difficulty that's never going to come up on a test. It's never going to come up in Math 218. In Math 220, the calculus for engineers, maybe these are important to do, but for us, they're just way more complicated than you'll ever get to see. They're not going to come up again in our class in terms of this level of complexity. They're not going to come up in Math 218. So let's just, for our sanity, let's skip 25 through 32 so that we can move on to the next problems that, if I was clever, I can do quickly. So we're going to skip on to the last part. So we've done a part 1 that had the product rule, a part 2 that has the quotient rule, and then part 3, it actually refers to the beginning part of this, but I'll pretend like I didn't notice that. Some of the functions in the first group of problems are the same functions that we saw earlier, but I'm going to pretend I don't know this comment here. Hint, I may have computed some of these derivatives already. So for problems 33 through 42, which is the rest of what we have left, that I might just put in a part 3. Waiting for the video to hiccup. I think I'm going to do a part 3 with the rest of this.